Something extraordinary pierced our cosmic neighborhood on July 1st, racing toward our star at a mind-bending 245,000 kilometers per hour. What astronomers discovered that day would challenge everything we thought we knew about our universe. This wasn't just another space rock drifting between stars minus. This was 3I Atlas, humanity's third confirmed visitor from beyond our solar system, carrying secrets that span 7 billion years. Imagine an object older than Earth itself, older than most stars we can see, hurtling through the void at speeds that make our fastest spacecraft look motionless. Within moments of detection, SETI's most powerful telescopes swiveled toward this ancient wanderer, desperately searching for something that could change everything might jump artificial signals. After decades of broadcasting our presence into the cosmos, had something finally decided to pay us a visit. Chile's Atlas Survey Telescope first caught this impossible intruder through automated systems designed to spot dangerous asteroids. But what the computers flagged defied every prediction model. The trajectory was wrong, the speed was impossible, and the timing felt too perfect to be coincidence. Within 24 hours, observatories across 6 continents confirmed humanity's most thrilling and terrifying discovery. This cosmic bullet had been hiding in plain sight, concealed behind the brightest, most crowded region of our night sky, directly in front of the galactic center's dense star fields. For weeks, it approached undetected, masked by millions of background stars. Was this strategic positioning mere chance or something far more deliberate? Unlike previous interstellar visitors that we discovered after they'd already rounded our sun and begun their exit journey, 3I Atlas was caught arriving. For the first time in human history, we had months to study an alien visitor before it completed its solar encounter. The implications sent shockwaves through the scientific community. Amateur astronomer Sam Dean realized earlier observations from June had been dismissed because nobody expected to find anything in such a visually chaotic region. The object had essentially chosen the perfect camouflage, remaining invisible until the very last moment. As SETI researchers scrambled their most sensitive equipment toward this 7-billion-year-old mystery, one question dominated every conversation. What if our century of radio transmissions had finally received an answer? When the Hubble Space Telescope turned its lens toward this cosmic intruder, what it captured defied conventional understanding. A teardrop-shaped dust envelope surrounded the nucleus, streaming material in patterns that contradicted millions of years of comet science. The Rubin Observatory team watched in amazement as this mysterious shroud expanded during their observation window, revealing a nucleus stretching across an estimated 11.2 kilometers. But the truly bewildering discovery emerged when astronomers analyzed the object's tail formation. Every comet humanity has ever studied follows the same basic rule: solar radiation pressure pushes their tails away from our star, creating those iconic curved trails we see in textbooks. 3-eyed Atlas shatters this fundamental law. Its dusty appendage points directly toward the sun, as if the object is deliberately ejecting massive particles in our star's direction, particles too heavy for radiation pressure to deflect. This backwards behavior suggests something far more complex than passive solar heating. The material isn't being blown away by our star's energy, it's being actively expelled toward it. Such deliberate ejection patterns have never been observed in natural comets, raising questions that make even veteran astronomers uncomfortable. The discovery timing adds another layer to this cosmic puzzle. Previous interstellar guests arrived unannounced. Miomor and 2I Borisov were both spotted during their exit phases, giving scientists only brief glimpses as they departed our neighborhood forever. 3I Atlas broke this pattern completely. We caught it arriving, providing months of precious observation time before its October 29th closest approach to our sun. Harvard's controversial astrophysicist Avi Loeb, who previously suggested Oumuamua might represent alien technology, has now published similar theories about 3 Atlas. While his colleagues remain skeptical, Loeb argues this visitor displays even stronger indicators of artificial origin. The scientific community finds itself divided between natural explanations and possibilities that challenge our understanding of what travels between the stars. Meanwhile, SETI researchers mobilized with unprecedented urgency. Within 24 hours of confirmation, the Allen Telescope Array began round-the-clock monitoring, collecting over 21 terabytes of data in just 7 days. This represents one of the most intensive searches for artificial signals ever conducted on any astronomical target. The monitoring protocols focus on detecting communication signals, electrostatic discharges that might occur when sunlight strikes artificial surfaces, and any evidence of course corrections or propulsion systems. An advanced probe would likely attempt to adjust its trajectory or reorient communication equipment to maintain contact with its origin point. As data analysis continues, one reality becomes increasingly clear: MEA's 3i Atlas exhibits behaviors that natural objects simply don't display, forcing humanity to confront possibilities we've never seriously considered. The most chilling evidence supporting artificial origins lies not in what 3i Atlas is, but in where it's heading. Advanced orbital mechanics reveal something that defies every law of cosmic probability. This 7-billion-year-old visitor is approaching our solar system's planets with surgical precision that would make NASA engineers envious. Venus will receive the first visit at 0.65 astronomical units, followed by Mars at an uncomfortably close 0.19 astronomical units, then Jupiter at 0.36 astronomical units. These aren't random flyby distances scattered across space. When astrophysicists calculated the mathematical probability of such synchronized planetary approaches occurring by pure chance, the numbers sent shockwaves through the scientific community. The cumulative odds, a microscopic 0.005%, is essentially impossible. Harvard's Avi Loeb and his research team have published findings that transform this statistical impossibility into something far more unsettling. Their analysis suggests we're witnessing deliberate mission planning, not cosmic coincidence. Every trajectory calculation points toward intentional targeting of our system's most significant worlds. But the synchronization doesn't end with planetary encounters. 3i Atlas has timed its arrival for maximum strategic advantage. During its closest solar approach on October 29th, Earth's view will be completely blocked by our star's brilliant disk. This solar eclipse creates perfect conditions for what aerospace engineers call a reverse Oberth maneuver. Such timing would allow the object to dramatically reduce its tremendous interstellar speed, potentially capturing itself into a stable solar orbit. The fact that this optimal deceleration window occurs precisely when humanity cannot observe raises questions that keep astronomers awake at night. Are we witnessing cosmic engineering designed to evade detection during critical operations? The implications extend far beyond simple trajectory analysis. If 3i Atlas represents artificial technology, its mission parameters suggest intelligence-gathering capabilities that dwarf our own space exploration achievements. Any decision-making entity would logically prioritize investigating worlds containing water, complex atmospheres, and biological signatures, all exactly the planets this object approaches most closely. SETI researchers have expanded their monitoring protocols beyond signal detection to include comprehensive spectroscopic analysis. Major observatories worldwide are conducting detailed chemical composition studies, searching for exotic compounds that don't belong in natural comets. Unusual molecular signatures could indicate construction materials, propulsion systems, or even shielding designed to protect sensitive equipment during interstellar travel. The search extends into behavioral analysis as well. Scientists are monitoring for course corrections, antenna repositioning, or any signs of active maneuvering that would conclusively prove artificial origin. Advanced probes would likely attempt to optimize their approach trajectories or maintain communication links with their origin points during critical mission phases. Loeb's research team has connected 3i Atlas to one of science fiction's most terrifying concepts, the dark forest hypothesis. This theory suggests our cosmic neighborhood teems with intelligent civilizations, but they remain hidden to avoid detection by hostile predators. The universe's apparent silence might not indicate absence of life, but rather successful camouflage by species that understand the stakes of cosmic visibility. Under dark forest conditions, any civilization broadcasting its location risks attracting attention from technologically superior predators. The hypothesis explains why decades of SETI searches have detected no clear artificial signals despite billions of potentially habitable worlds throughout our galaxy. Everyone is hiding, waiting, listening. 3i Atlas might represent either a scout from predatory intelligence or a refugee fleeing cosmic violence. Its approach timing and trajectory suggests sophisticated understanding of our solar system's dynamics, indicating prolonged observation or advanced computational modeling. The object's 7 billion year age means it potentially witnessed the rise and fall of countless civilizations throughout galactic history. The scientific community remains deeply divided over these interpretations. Oxford University's Chris Lintott dismissed artificial origin theories as nonsense on stilts, arguing that extraordinary claims require extraordinary evidence. Traditional astronomers prefer conventional explanations involving unusual but natural comet behaviors, pointing out that our understanding of interstellar objects remains limited, given we've only confirmed 3 examples. However, even skeptics acknowledge the statistical anomalies are difficult to explain through random processes. The synchronized planetary approaches, optimal solar concealment timing, and unprecedented physical characteristics create a pattern that challenges natural formation theories. Marshall Eubanks from Space Initiatives has identified multiple spacecraft and Mars orbiters positioned to observe Three-Eyed Atlas during its planetary encounters. These platforms could detect course corrections, surface changes, or deployments of smaller objects that would definitively prove artificial origin. Any technology advanced enough to traverse interstellar distances might deploy reconnaissance probes during optimal observation windows. The trajectory analysis reveals additional concerning details. Three-Eyed Atlas approaches with a retrograde orientation tilted 175 degrees relative to our solar system's natural motion, essentially moving backward compared to everything else. This alignment closely matches the orbital planes of major planets, suggesting intimate knowledge of our system's architecture. Natural interstellar objects typically follow chaotic trajectories, influenced by random gravitational encounters during millions of years wandering between stars. The precise planetary targeting displayed by Three-Eyed Atlas indicates either impossible coincidence or deliberate navigation towards specific destinations. Loeb has proposed attempting radio communication during the object's approach, though he warns such contact carries significant risks. Any intelligence capable of interstellar travel might perceive artificial signals as threats, potentially triggering defensive responses that could reach Earth within months rather than millennia. The monitoring strategy includes watching for enhanced unidentified aerial phenomena activity immediately following Three-Eyed Atlas's October 29 perihelion passage. This anticipates the possibility that the primary object might deploy smaller reconnaissance platforms toward Earth and other targeted worlds during its closest solar approach. Whether representing natural phenomenon or artificial technology, Three-Eyed Atlas has already succeeded in forcing humanity to confront uncomfortable realities about our cosmic isolation. The mathematical precision of its planetary approaches suggests we live in a universe where intelligence operates on scales and timelines that dwarf human comprehension. The next few months will determine whether we're witnessing the approach of an ancient comet displaying unusual characteristics, or something far more significant, first contact with intelligence that has been watching our solar system for billions of years, finally deciding the time has come for closer examination. October 29th, 2025 marks a date that could redefine humanity's understanding of our cosmic neighborhood. On this day, Three-Eyed Atlas will reach perihelion, its closest approach to our Sun, at 1.36 astronomical units, positioned precisely between Earth and Mars. What makes this encounter truly extraordinary isn't just the proximity, but the perfect timing of total concealment from human observation. During this critical phase, Three-Eyed Atlas will disappear completely behind our star's brilliant disk, creating a natural solar eclipse that renders every Earth-based telescope useless. The Hubble Space Telescope, the James Webb Space Telescope, and every ground-based observatory on our planet will be powerless to observe what unfolds during the most important moments of this 7 billion year journey. The timing appears impossibly convenient for any operations requiring absolute secrecy. Natural cosmic mechanics rarely provide such perfectly orchestrated concealment opportunities. If Three-Eyed Atlas was simply wandering randomly through space, the mathematical probability of its closest solar approach coinciding with Earth's observational blackout would be astronomically remote. This 3-month invisibility window creates ideal conditions for what aerospace engineers recognize as a reverse Oberth maneuver. Unlike traditional spacecraft that accelerate at closest approach to maximize escape velocity, A reverse maneuver applies braking thrust at perihelion to achieve maximum deceleration. For an object traveling at 3 Atlas's tremendous interstellar speed, this represents the optimal opportunity to slow down enough to become gravitationally captured by our solar system. The strategic implications are staggering. Any intelligence planning long-term solar system reconnaissance would naturally choose this hidden approach window for critical operations. Course corrections, probe deployments, or communication bursts with distant controllers could occur completely undetected during the solar eclipse period. While Earth remains blind, several spacecraft positioned throughout our solar system will maintain clear sightlines to the mysterious visitor. Mars orbiters and surface rovers will have unobstructed views during the entire perihelion passage, potentially providing humanity's only real-time observations of whatever transpires behind our star. NASA's Psyche mission, currently traveling toward its namesake asteroid, will be positioned approximately 0.44 astronomical units from 3 ILS during the encounter. The Jupiter Icy Moons Explorer could potentially redirect its instruments toward the object during its 0.36 astronomical unit approach to the gas giant. These distant observations become critical because they might detect activities invisible to Earth-based telescopes. Any artificial maneuvering, signal transmission, or deployment of smaller reconnaissance probes would be immediately apparent to spacecraft monitoring from alternative vantage points. The precision planetary targeting adds another layer of concern to the October blackout. 3I Atlas approaches Venus, Mars, and Jupiter with mathematical accuracy that defies natural explanation. The cumulative probability of such synchronized encounters occurring by chance calculates to 0.005%, meaning essentially impossible, without deliberate navigation planning. Marshall Eubanks from Space Initiatives has identified multiple spacecraft positioned to observe potential artificial behaviors during planetary approaches. These platforms could detect the course corrections, surface changes, or probe separations that would definitively prove technological origin. Any civilization capable of interstellar travel would likely deploy reconnaissance assets during optimal observation windows. The observational gap extends from late September through early December 2025, encompassing the period when any artificial technology would most naturally reveal its true nature. Natural comets typically display their most dramatic activity during perihelion passage as solar heating vaporizes surface materials, creating spectacular tails and expanding comas visible across the solar system. Yet 3I Atlas defies these fundamental expectations. Despite approaching our star and experiencing increasing thermal stress, the object displays virtually none of the outgassing activity that defines normal cometary behavior. While some observers report marginal signs of a faint coma and potential tail-like features, these remain far subtler than expected for a 20-kilometer object encountering intense solar radiation. The tail behavior presents perhaps the most disturbing anomaly. Vera Rubin Observatory observatories has revealed dusty material streaming directly toward the sun rather than away from it, completely opposite to the physics governing every comet humanity has studied. Solar radiation pressure should push lightweight particles away from our star, creating those iconic curved trails visible in astronomical photographs. Instead, 3I Atlas appears to be actively ejecting heavy particles in the solar direction Misona, material too massive for radiation pressure to deflect. This suggests deliberate expulsion rather than passive heating, indicating internal processes that don't exist in natural comets. The missing outgassing becomes even more significant when compared to 2I Borisov, the previous interstellar comet that displayed spectacular activity during its 2019 solar encounter. Borisov developed dramatic tails and expanding comas exactly as predicted by established comet science, proving that interstellar visitors follow the same physical laws as solar system natives. 3I Atlas breaks these established patterns completely. Its resistance to normal solar heating effects suggests either exotic composition, unlike any known comet material, or artificial shielding, designed to protect sensitive internal components during close stellar approaches. Avi Loeb has assigned his Galileo project team to monitor for enhanced unidentified aerial phenomena activity immediately following the October 29th perihelion passage. This strategy anticipates that any probes deployed during the hidden solar approach might arrive at Earth and other targeted planets in the months after perihelion. The team will use 3 dedicated observatories to search for artificial objects that might have been quietly released while human observation remained blocked. Such reconnaissance platforms would be virtually impossible to detect during deployment due to their small size and the tremendous speeds involved, but might become visible once they begin independent operations. The convenient solar eclipse timing forces uncomfortable conclusions about either impossible natural coincidence or deliberately planned mission execution. The mathematical precision of planetary targeting combined with optimal concealment timing suggests intelligence operating on scales that dwarf human comprehension. As September approaches and 3i Atlas begins its final approach towards solar conjunction, humanity faces an unprecedented situation. For the first time in our species' history, we've detected what appears to be artificial technology approaching our solar system, yet will be completely blind during its most critical operational phase. The next few months will determine whether we're witnessing the most improbable natural event in solar system history, or the execution of a reconnaissance mission planned across billions of years, by intelligence that has been patiently watching our cosmic neighborhood, finally deciding the time has come for closer examination of the young civilization orbiting the third planet from our unremarkable yellow star. The true magnitude of what's approaching our solar system becomes clear when astronomers reveal 3i Atlas's staggering dimensions. Current estimates place this cosmic visitor at approximately 20 kilometers in diameter, over 100 times larger than Oumuamua, and vastly exceeding every theoretical model for natural interstellar debris. We're not dealing with a simple space rock, but rather a mountain-sized object that somehow achieved velocities capable of crossing the void between stars. The Vera Rubin Observatory's latest measurements confirm that even the solid nucleus alone spans 11.2 kilometers, making the core larger than both previous interstellar visitors combined. When including the surrounding coma and material ejection envelope, the total observable structure extends up to 15 kilometers across Myd's-Tyr, creating a cosmic giant that transforms telescope images into spectacular rainbow-colored displays against the starfield background. This enormous scale fundamentally changes every calculation about 3i Atlas's nature and origin. David Jewett's comparison to tracking a rifle bullet for 1,000th of a second breaks down completely when applied to something this massive. We're not observing a bullet-sized projectile, but rather a mountain that somehow achieved interstellar velocities, a feat that challenges our understanding of stellar system dynamics and object ejection mechanisms. The size implications for artificial origin theories are profound. Any technological construct measuring 20 kilometers would represent engineering capabilities that dwarf human achievements by orders of magnitude. Such dimensions approach the scale of substantial space habitats or industrial complexes, capable of housing entire populations during extended interstellar journeys. While size alone doesn't prove artificial construction, it demonstrates the technological sophistication required if 3i Atlas represents manufactured technology. Yet the object's behavior continues defying expectations established by its massive scale. Spectroscopic analysis reveals material ejection rates of 0.1 to 1 kilograms per second, consisting of micrometer to millimeter-sized particles expelled at modest velocities between 0.01 and 1 meter per second. For such an enormous object experiencing intense solar radiation, these activity levels seem surprisingly restrained. Natural comets of this size should produce spectacular outgassing displays visible across the solar system as solar heating vaporizes their icy surfaces. The calculated mass loss rate suggests substantial material ejection that should create dramatic tail formations and expanding comas far exceeding what observers actually detect. This disconnect between theoretical predictions and observed reality adds another layer of mystery to 3i Atlas's already anomalous characteristics. The limited cometary activity becomes even more puzzling when considering the object's 7 billion-year cosmic journey. Extended exposure to interstellar radiation and micrometeorite bombardment should have created protective surface crusts that inhibit normal outgassing. Yet the observed activity levels remain inconsistent with expected surface modifications from such prolonged space weathering. Multiple explanations could account for this unusual behavior. The object might be depleted of volatile materials after billions of years wandering through the cosmic void, leaving only refractory compounds that resist vaporization under solar heating. Alternatively, artificial construction using non-volatile materials would naturally exhibit limited outgassing regardless of thermal stress. Early observations in July initially questioned whether 3I Atlas qualified as an asteroid or comet, with astronomers including Alan Hale reporting no obvious cometary features during initial detection periods. Only follow-up observations on July 2nd by multiple observatories confirmed marginal coma development, with potential tail elongation measuring 3 arcseconds in angular length. David Jewett and Jane Liu, using the Nordic Optical Telescope, confirmed clear activity with diffuse appearances, though levels remained modest compared to expectations for such a massive object. The anomalous tail direction mean, pointing toward rather than away from the Sun, suggests active material ejection mechanisms rather than passive solar heating effects. This behavior eliminates one of astronomy's primary methods for distinguishing natural objects from artificial constructs. Without obvious outgassing signatures following established physical laws, researchers must rely on trajectory analysis, surface reflectivity measurements, and potential signal emissions to determine the visitor's true nature. The classification limbo becomes increasingly uncomfortable as evidence accumulates. 3I Atlas displays too much activity to qualify as a simple asteroid, yet exhibits too little normal cometary behavior to fit established comet categories. Its characteristics occupy a scientific gray zone that challenges traditional astronomical classifications. The massive scale creates significant implications for any potential intercept missions. Spacecraft designed for typical asteroid or comet encounters would be completely inadequate for investigating an object of this magnitude. Chemical rocket technology cannot achieve the velocity changes necessary to match 3A Atlas's tremendous speed, making physical examination impossible using current propulsion systems. Future interstellar missions may require complete redesign to accommodate massive objects rather than small debris fragments. The discovery forces humanity to reconsider both detection capabilities and fundamental assumptions about what travels through the spaces between stars. Statistical analysis reveals the profound improbability of detecting such a large interstellar visitor. Computational models predict much smaller typical dimensions for debris naturally ejected from stellar systems, making objects of this scale extraordinarily rare. The mathematical likelihood of encountering something this massive approaches astronomical impossibility, suggesting either incredible fortune or deliberate approach timing. Asta Taylor from the University of Michigan notes that exact size determination remains challenging due to measurement uncertainties, but current estimates consistently place 3I Atlas among the largest objects ever observed transitioning through our solar system. The rainbow-colored appearance in time-lapse photography creates visual spectacles that far exceed the subtle characteristics of previous interstellar visitors. The enormous dimensions correlate with substantial material reserves capable of sustaining measured ejection rates over extended periods. However, the modest expulsion velocities seem inconsistent with expectations for such a massive object under solar heating, adding yet another anomaly to the growing list of inexplicable behaviors. As humanity prepares for the October 29th solar eclipse that will hide 3I Atlas during its most critical approach phase, the object's massive scale adds weight to every theory about its ultimate purpose. Whether representing the largest natural comet ever detected or the most ambitious artificial construct imaginable, 3I Atlas has already succeeded in forcing our species to confront possibilities that extend far beyond previous scientific frameworks. The next few months will determine whether we're witnessing an unprecedented natural phenomenon or first contact with engineering capabilities that render human technology primitive by comparison. Either conclusion will fundamentally alter humanity's understanding of our place in a universe that may be far more populated and purposeful than we ever dared imagine. Deep within the archives of our galaxy's history lies a region that holds the universe's most ancient secrets, the Milky Way's thick disk. This vertically extended neighborhood houses stellar populations that witnessed the cosmos when it was young, raw, and chemically primitive. Analysis of 3I Atlas's trajectory reveals it originates from this primordial galactic realm, making it potentially the oldest matter humanity has ever directly observed. The thick disk connection emerged through meticulous analysis of the object's galactic velocity components. When 3I Atlas arrived at our solar system's doorstep, it carried the unmistakable signature of ancient stellar populations, moving away from the galactic center with a radial velocity of -51 kilometers per second, while simultaneously ascending through the galactic plane at +18.5 kilometers per second. The object's motion perfectly matches thick disk dynamics. Matthew Hopkins and his Oxford colleagues determined with 68% confidence that objects originating from this ancient galactic region typically range between 7.6 and 14 billion years old. This age estimate places 3A Atlas among the most primordial matter ever encountered, potentially older than complex life on Earth, older than our solar system's formation, possibly approaching the age of the universe itself. The implications stretch across cosmic timescales that challenge human comprehension. During its billions of years wandering through interstellar space, 3I Atlas experienced countless gravitational encounters with stars, planetary systems, and stellar nurseries. Each encounter modified its trajectory while adding momentum through gravitational slingshot effects, gradually building the tremendous velocity we observe today. The object's current speed serves as a cosmic odometer, recording eons of galactic wandering through accumulated momentum. Chris Lintott from Oxford University participated in computer modeling attempts to trace 3I Atlas backward through its galactic journey. These simulations face enormous computational challenges when trying to identify potential origin points within the thick disk region. As David Jewett noted, projecting backward from such a brief observation window to determine ultimate origins approaches mathematical impossibility across such vast timescales. The thick disk represents approximately 2/3 of our galaxy's stellar population, creating a vast reservoir of potential source systems. However, the advanced age of thick disk stars means many original planetary systems have likely been disrupted by stellar evolution. The parent star that originally hosted 3I Atlas could have completed its entire life cycle, possibly ending as a white dwarf, neutron star, or even a black hole. Any original planetary system might have been destroyed during the parent star's evolutionary death throes. Thick disk stars typically contain lower concentrations of heavy elements compared to younger stellar populations like our Sun. This reduced metallicity reflects formation during earlier cosmic epochs when fewer processed materials existed throughout the galaxy. If 3I Atlas formed in this chemically primitive environment, its composition might preserve signatures from the universe's early stages of stellar nucleosynthesis, a holographic sample from cosmic infancy. The ancient trajectory also explains why detecting 3I Atlas proved so challenging despite its enormous 20-kilometer dimensions. The object's approach direction toward the galactic center positioned it against the densest star fields visible from Earth, where millions of crowded background stars created natural camouflage that made detection extremely difficult until the final approach phase. This strategic concealment allowed 3I Atlas to approach relatively close before discovery, limiting our observation window for studying its inbound journey. Whether this camouflage represents cosmic coincidence or deliberate positioning remains one of the most unsettling questions surrounding this ancient visitor. The thick disk connection adds profound weight to artificial origin theories. If 3I Atlas represents technology rather than natural matter, it would indicate that intelligent civilizations existed in the thick disk region billions of years ago, long before most planetary systems in our current galactic neighborhood had even formed. Such ancient technological societies would fundamentally alter our understanding of when and where intelligent life emerged in cosmic history. Meanwhile, SETI researchers have mobilized unprecedented resources to analyze 3I Atlas for potential artificial signals. Within just 1 week of beginning observations, the Allen Telescope Array accumulated over 21 terabytes of data, mitral equivalent to thousands of hours of high-resolution video. This massive dataset represents one of the most comprehensive attempts ever undertaken to detect technological signatures from a specific astronomical object. Dr. Wael Farah leads the monitoring efforts, targeting both narrowband emissions that could indicate artificial communications and natural radio emissions from dust particles and molecular compounds. The dual approach recognizes that three-eyed Atlas might reveal its true nature through either deliberate transmissions or unusual natural radio characteristics that deviate from expected patterns. The search protocols specifically monitor for radio communications, electrostatic discharges caused by sunlight interacting with artificial surfaces, and any evidence of maneuvering or course corrections. Advanced probes might attempt to maintain communication links with their origin points or broadcast identification signals to announce their presence to potential receiving civilizations. Earth's own electromagnetic signature provides a template for recognizing technological emissions. Over 100 years of television and radio broadcasts have created an expanding sphere of artificial signals extending 200 light-years from our planet. These transmissions would be easily recognizable as technological due to their repetitive patterns and narrow bandwidths, demonstrating how other civilizations might be detected through their electromagnetic footprints. The Allen Telescope Array's 34-meter dishes provide the sensitivity necessary to detect weak signals from objects at 3i Atlas's distance. Radio communication across interstellar distances faces tremendous signal degradation, requiring sophisticated antenna systems and processing techniques to identify artificial patterns against cosmic background noise. Initial analysis of the 21-terabyte dataset has not revealed obvious artificial signals, though data processing continues using sophisticated algorithms designed to identify subtle patterns that might indicate technological origin. Modern SETI techniques employ artificial intelligence systems to process enormous data volumes, searching for candidate signals that require human verification. The monitoring effort builds upon decades of SETI experience, including projects like Serendip that have analyzed deep space radio telescope data for years. The Breakthrough Listen initiative provides substantial funding and resources, making comprehensive monitoring of 3i Atlas possible on an unprecedented scale. As 3i Atlas continues its approach toward the October solar eclipse that will hide it from Earth-based observation, the combination of ancient origins and intensive SETI monitoring creates a unique moment in human history. We stand at the threshold of potentially confirming that intelligence has been traveling through our galaxy for billions of years, carrying secrets from cosmic epochs that predate everything we consider familiar in our local stellar neighborhood. The mathematical precision of 3i Atlas's approach becomes even more unsettling when astronomers analyze its orbital alignment with our solar system's architecture. The object follows a trajectory that coincidentally aligns with the orbital planes of our planets, creating what researchers call ecliptic alignment MIND, a phenomenon so rare it occurs in only 0.2% of randomly arriving interstellar visitors. Specifically, 3i Atlas's path tilts 175 degrees with respect to the ecliptic, placing it in retrograde motion inclined just 5 degrees from the planetary orbital plane. This close alignment represents astronomical precision that forces uncomfortable questions about intentional targeting versus impossible natural coincidence. The retrograde approach means the object travels opposite to planetary motion around our Sun, creating relative velocities that make any human intercept mission completely impractical using current technology. At perihelion, 3i Atlas will achieve 68 km per second relative to our star, while Earth orbits at 30 km per second in the opposite direction. This creates a relative velocity difference of 98 km per second (m), speeds that render chemical rocket intercepts fantasies rather than feasible missions. The tremendous velocity gap ensures that humanity remains a passive observer of whatever unfolds during the visitor's solar system passage. The ecliptic alignment enables something that natural wandering objects cannot accomplish as recomprehensors of multiple worlds during a single flyby mission. The precisely calculated trajectory brings 3i Atlas within 0.65 astronomical units of Venus, 0.19 astronomical units of Mars, and 0.36 astronomical units of Jupiter. The cumulative probability of such close encounters with major planets, given random arrival timing, calculates to an impossibly low 0.005%. Any artificial intelligence controlling this ancient visitor could gather detailed information about planetary characteristics, atmospheric compositions, and potential habitability during these strategically timed approaches. The trajectory creates perfect opportunities for deploying smaller reconnaissance probes toward individual worlds during each encounter, with deployment occurring at optimal velocities and positions for extended observation missions. The orbital alignment provides additional strategic advantages for comprehensive data collection from multiple observation platforms. Mars-based instruments will maintain clear sight lines during 3I Atlas's approach when Earth-based telescopes cannot observe due to solar glare. The Jupiter encounter allows the Jupiter Icy Moons Explorer and other outer system missions to track the object from completely different perspectives, potentially revealing details invisible from any single vantage point. This precise ecliptic alignment also explains why 3I Atlas remained undetected until July, despite its enormous 20-kilometer dimensions. The approach direction toward the galactic center positioned it against the densest star fields in our sky, where millions of background stars create natural camouflage that makes detection extraordinarily difficult until the final approach phases. The alignment timing creates perfect conditions for potential course corrections during the hidden perihelion passage behind our Sun. The 3-month solar eclipse period provides an ideal window when any maneuvering would remain invisible from Earth-based observation. A reverse Oberth maneuver during this concealed period could slow the object enough to achieve gravitational capture within our solar system, transforming it from a passing visitor into a permanent resident. Such timing precision suggests deliberate mission planning rather than cosmic coincidence. Future interstellar missions might benefit from studying 3I Atlas's trajectory optimization techniques, whether the object represents natural phenomenon or artificial technology. The European Space Agency's planned Comet Interceptor mission could potentially learn from the efficient multiplanetary approach demonstrated by this mysterious visitor. The perfect orbital alignment forces humanity to choose between accepting astronomical improbability or acknowledging the possibility of deliberate trajectory planning by intelligence capable of comprehensive solar system analysis. The mathematical precision challenges every assumption about random cosmic encounters, while suggesting purposes that extend far beyond casual observation. This precision becomes even more disturbing when considered alongside humanity's own attempts at interstellar communication. On November 16, 1974, the Arecibo radio telescope broadcast humanity's first deliberate message toward the globular cluster Messier 13, located 22,200 light-years away. Created by renowned SETI researcher Frank Drake and science communicator Carl Sagan, this graphic message showcased human technical advancement while announcing our presence to potential cosmic neighbors. The Arecibo transmission utilized the observatory's megawatt transmitter, coupled with its massive 305-meter antenna, creating tremendously powerful signals capable of reaching across thousands of light-years. The broadcast targeted approximately 300,000 stars within the M13 cluster, positioned toward our galaxy's outskirts. However, the 25,000-year travel time to reach the target and another 25,000 years for any response means humanity would wait 50,000 years for a reply from M13. But what about objects already traveling through our cosmic neighborhood when we began broadcasting? Earth's inadvertent radio transmissions started much earlier than the deliberate Arecibo message. The first public radio broadcast occurred on December 24, 1906, and these signals have been traveling outward into space for over 100 years. Currently, our television and radio broadcast signals extend approximately 200 light-years from Earth in an ever-expanding sphere of artificial electromagnetic radiation. Any intelligence within this sphere could have detected our presence decades ago, recognizing these transmissions as artificial due to their repetitive patterns and narrow bandwidths. Earth's radio emissions provide a clear template for how technological civilizations announce themselves through electromagnetic radiation. These signals have already reached over 15,000 nearby stars, including notable targets like Vega, Aldebaran, Barnard's star, Sirius, and Proxima Centauri. If intelligent life exists around any of these stellar systems, they could have been monitoring human broadcasts for decades. The timing becomes profoundly unsettling when considered alongside 3I Uranus's ancient galactic journey. If this object has been wandering our galaxy for billions of years, it could have been positioned to detect Earth's early radio signals during the past century. An intelligence capable of interstellar travel would recognize artificial transmissions immediately, potentially triggering reconnaissance missions toward the source of these unexpected broadcasts. The mathematical precision of 3i Atlas's multiplanetary approach, combined with its arrival timing shortly after humanity's century of radio emissions, creates a pattern that transcends coincidence. We may be witnessing the ultimate response to our inadvertent announcement that intelligent life exists around an unremarkable yellow star in the galaxy's outer spiral arm. The tremendous speeds achieved by 3i Atlas during its billions of years wandering through space tell a story of countless gravitational encounters with stellar systems, encounters that could have systematically altered its trajectory toward detected signal sources. Our century of radio broadcasts might have served as an inadvertent beacon, attracting precisely the kind of interstellar attention we never considered when we began transmitting into the void. Beyond the famous Arecibo message, humanity has launched numerous deliberate attempts at interstellar communication. Soviet researchers transmitted signals to Venus encoded with Mir, Lenin, and USSR in Morse code, while more recent efforts between 1999 and 2016 sent carefully crafted messages to stars positioned 17 to 69 light-years away. Scientists worldwide are currently developing the Beacon in the Galaxy message, combining elements from all previous METI attempts into humanity's most comprehensive interstellar announcement. The dark forest hypothesis adds chilling dimensions to our broadcast history. If our galaxy harbors hostile civilizations that systematically eliminate potential threats, our radio signals might have inadvertently painted a massive target on Earth. This terrifying theory suggests that advanced civilizations maintain absolute silence to avoid detection by cosmic predators, yet humanity has been broadcasting its location with increasing intensity for over 100 years. 3i Atlas might represent either a direct response to our transmissions or reconnaissance, preceding more substantial contact. Avi Loeb suggests that if the object proves artificial, humanity should consider attempting radio communication during its approach. However, he warns that such contact carries enormous risks and the alien intelligence might perceive our signals as threats and respond defensively. Unlike distant communications requiring thousands of years for transmission, 3i Atlas could respond within months, potentially reaching Earth by Christmas 2025. The Arecibo echo might not be the distant reply we anticipated, but rather the approaching shadow of something that has been listening to our broadcasts all along, finally deciding to investigate the source of these artificial signals emanating from an unremarkable yellow star. Meanwhile, humanity's most ambitious messages continue their own journeys into the same interstellar medium that 3i Atlas has been traversing. Both Voyager spacecraft, launched in 1977, carry Golden Record's photograph discs intended to communicate humanity's story to any extraterrestrial intelligence encountering these wandering ambassadors. Following their predecessors Pioneer 10 and 11 with their simple plaques, the Voyager missions transport messages from Earth as they venture into interstellar space. Created under Carl Sagan's visionary leadership, these golden records contain 116 images, natural sounds, spoken greetings in 55 languages, and musical selections representing human cultural diversity. The records serve as time capsules carrying humanity's essence across cosmic distances, designed to survive millions of years traveling through space. Voyager 1 achieved the remarkable distinction of becoming the first human-made object to enter interstellar space, crossing the heliopause in 2012. Both spacecraft have now reached the region between stars where galactic plasma flows, the same interstellar medium that 3i Atlas has been navigating for potentially billions of years. The probe continues transmitting scientific data, though signals now require over 22 hours to reach Earth due to tremendous distances. The Golden Record contents were meticulously selected to represent Earth's diversity and human achievements. Instructions for playing the record are encoded on the cover, alongside a pulsar map and hydrogen molecule diagram designed to help recipients locate our planet. The 116 images include mathematical concepts, human anatomy, technological achievements, and natural phenomena, while the audio portion contains greetings, music, and sounds representing Earth's biosphere. A spoken greeting in English by United Nations representatives formally announces humanity to the cosmos, declaring our peaceful intentions while showcasing our linguistic diversity through dozens of languages. These carefully chosen words might represent the first alien encounter with human speech, assuming the records eventually find their intended audience. Recently, Voyager 1 has experienced concerning communication problems that eerily parallel the mysterious nature of 3ANLAR. Since November 2023, the spacecraft has been transmitting unreadable data streams, though engineers successfully decoded meaningful signals in March 2024. The decoded message contained a complete readout of the flight data subsystem memory, allowing NASA to diagnose the communication failures. These technical difficulties highlight the challenges of maintaining contact across interstellar distances. Voyager's signals require 22.5 hours each way to reach Earth, making real-time troubleshooting impossible. The spacecraft uses 23-watt radios transmitting through 3.7-meter antennas to 34-meter dishes on Earth, demonstrating the technological requirements for interstellar messaging despite the low transmission power. The Pioneer and Voyager missions established crucial precedents for interstellar communication. Pioneer plaques featured mathematical concepts, human figures and pulsar maps designed to be universally understandable to any technological civilization. The visual representation of humans from these plaques has been reused in subsequent messages, including radio transmissions, creating recognizable signatures for human communication attempts. Pioneer 10, launched in 1972, as NASA's first mission to the outer planets, followed by Pioneer 11 1 year later, continued their journeys into deep space after successful exploration of Jupiter and Saturn. These spacecraft carry humanity's first deliberate messages to potential extraterrestrial intelligence through plaques designed by Carl Sagan and mounted on the spacecraft exteriors. Until recently, Pioneer 10 held the distinction of being the most distant human-made object from Earth. The plaques feature carefully designed symbols intended to be universally comprehensible to any technological civilization, including pulsar maps showing Earth's location relative to 14 pulsars, hydrogen molecule diagrams establishing universal measurements, and line drawings of naked human figures. Both spacecraft will continue their interstellar journeys for potentially millions of years, carrying humanity's messages into regions where other interstellar travelers like 3 Atlas have wandered. Over the next 1,000, million, and billion years, these probes will explore our universe, carrying our human legacy through cosmic darkness. Carl Sagan wrote that the golden record represents a present from a small distant world, a token of our sounds, our science, our images, our music, our thoughts, and our feelings. The record concludes with the hopeful message, "We are attempting to survive our time, so we may live into yours." Now, as 3O Atlas approaches from the same interstellar void that Voyager has entered, we must confront whether our messages have already found their intended audience. The golden records travel outward while 3O Atlas approaches inward, night two ships passing in the cosmic night, carrying messages across the darkness between stars, possibly destined for an encounter that will determine humanity's cosmic future. Voyager 1 currently races through interstellar space at approximately 17 kilometers per second, maintaining the fastest heliocentric recession velocity of any human-built craft. Yet despite this remarkable speed, all 4 pioneering ambassadors minus Pioneer 10 and 11, plus both Voyager spacecraft, now navigate through the identical cosmic medium that 3I Atlas has been crossing for eons. This convergence represents humanity's first intersection with the ancient pathways traveled by interstellar visitors. The evolution from Pioneer's basic plaques to Voyager's comprehensive golden records demonstrates our species' maturing approach to cosmic communication, where Pioneer offered fundamental information about human appearance and Earth's galactic coordinates. Voyager provided extensive cultural documentation including musical compositions, linguistic diversity, and detailed visual representations of our civilization. Contemporary projects like the Beacon and the Galaxy message synthesize elements from all previous attempts, suggesting continuous refinement of our interstellar diplomatic strategies. The profound irony emerges when considering that human probes traveling at comparable velocities would remain virtually undetectable if they represented alien technology visiting our solar system. Current astronomical detection systems can track objects measuring only 10 to 20 meters across solely within Jupiter's orbital distance. If an extraterrestrial probe matching our Voyager specifications approached from interstellar distances, we would likely miss it entirely until it penetrated the asteroid belt. This technological limitation implies that numerous compact interstellar visitors might traverse our system completely unnoticed. Our detection bias favors massive objects like 3 Albus while potentially missing sophisticated reconnaissance platforms designed for stealth operations. The realization forces uncomfortable questions about what else might be studying us from beyond our observational capabilities. Pioneer and Voyager missions will continue their cosmic expeditions for potentially billions of years, transporting humanity's earliest diplomatic overtures into the galactic community. These spacecraft represent our species' inaugural steps toward interstellar citizenship, announcing both technological capabilities and peaceful intentions to whatever intelligence might discover them wandering through the cosmic dark. The messages they carry establish precedents for how emerging civilizations might introduce themselves to established cosmic neighborhoods. Now, as 3i Aeolus approaches with characteristics that defy natural explanations, we must contemplate whether our pioneering postcards have already been intercepted and analyzed by intelligence that predates our civilization by billions of years. If this interstellar visitor has been wandering our galaxy since before Earth's formation, it could have encountered evidence of countless technological civilizations, including potentially humanity's expanding electromagnetic signature. The synchronized timing of 3i Atlas's arrival with our era of space exploration and interstellar messaging transcends mere coincidence. Our planet has been broadcasting artificial radio signals into space for over 100 years, beginning with that first public transmission on December 24, 1906. These television and radio broadcasts now constitute an expanding electromagnetic sphere, extending approximately 200 light-years from Earth. The signals have already reached over 15,000 nearby stellar systems, including prominent targets like Vega, Aldebaran, Barnard's Star, Sirius, and Proxima Centauri. Any intelligence within this growing sphere could have detected unmistakable evidence of technological civilization decades ago. These inadvertent broadcasts would be immediately recognizable as artificial due to their repetitive patterns and narrow bandwidths, creating distinctive signatures that differ dramatically from natural cosmic radio sources. The detectability of Earth's emissions demonstrates how exposed technological civilizations become to observation by advanced neighbors. Despite some signal degradation from Earth's ionosphere, the unintentional nature of most transmissions means civilizations reveal themselves long before conscious attempts at interstellar communication. We became visible to cosmic observers before realizing we were broadcasting our presence. The timing correlation with 3i Atlas's approach creates deeply unsettling implications. If this object has been traversing interstellar space for billions of years, gravitational encounters with stellar systems could have systematically modified its trajectory toward electromagnetic anomalies like Earth's radio emissions. Each stellar encounter during its cosmic journey added momentum while potentially redirecting its path towards signal sources. Our century of broadcasts might have functioned as an inadvertent homing beacon, guiding ancient intelligence toward our previously anonymous solar system. The progression of human signal technology reveals our advancing capabilities to any monitoring intelligence, creating a readable timeline of our species' rapid development from primitive radio to space exploration capabilities. Current deep space network infrastructure demonstrates the sophistication required for interstellar surveillance. The network employs massive antenna arrays and extraordinarily sensitive receivers capable of detecting extremely weak signals across vast distances. These identical technologies that enable communication with distant spacecraft could be utilized by advanced civilizations to monitor our planet's electromagnetic emissions continuously. The dark forest hypothesis adds terrifying context to our broadcast history. If our galaxy harbors predatory civilizations that systematically eliminate potential threats, our radio signals might have inadvertently marked Earth as a priority target. This hypothesis suggests that prudent civilizations maintain absolute silence to avoid detection, yet humanity has been announcing its presence with increasing intensity for over a century. 3i Atlas might represent reconnaissance preceding more direct contact, or worse, multi-threat assessment before elimination. Low warns that attempting radio communication with this nearby visitor carries significant risks compared to distant SETI targets. Unlike signals directed towards star clusters thousands of light-years away, communication with 3i Atlas could prompt immediate responses. Any intelligence controlling this object could reach Earth within months rather than millennia, transforming first contact scenarios from theoretical possibilities into potentially imminent realities. The proximity factor eliminates the comfortable buffer of cosmic distances that has always separated us from the consequences of our interstellar messaging attempts. Voyager 1 now transmits from genuine interstellar space, having crossed the heliopause boundary on August 25, 2012, becoming the first human-made object to enter the region between stars. The spacecraft continues operating after almost 50 years, though signals require over 22 hours to reach Earth due to its tremendous distance exceeding 24 billion kilometers. Recent communication anomalies with Voyager 1 have created disturbing parallels to the mysterious nature of 3I Atlas. Since November 2023, the spacecraft has transmitted unreadable data streams consisting of binary patterns alternating ones and zeros, replacing normal telemetry with incomprehensible sequences that echo the enigmatic signals we might expect from artificial interstellar visitors. As 3I Atlas approaches its October solar eclipse and Voyager continues its journey into the same interstellar medium, humanity faces the ultimate cosmic question: are we witnessing the convergence of our own messages with intelligence that has been patiently listening from the darkness between stars, finally deciding to investigate the source of these artificial signals emanating from a young civilization orbiting an unremarkable yellow star? NASA engineers described Voyager 1's communication crisis using a haunting analogy: maintaining a connected phone call, while the spacecraft's voice transformed into a monotonous dial tone. Since November 2023, humanity's most distant ambassador has been transmitting corrupted data streams, replacing meaningful telemetry with repetitive patterns of alternating ones and zeros that echo the binary language of artificial intelligence. The timing creates unsettling synchronicity with our growing awareness of 3-eyed Atlas approaching through the same interstellar medium. As we discovered this ancient visitor racing toward our solar system, our pioneering spacecraft simultaneously began speaking in incomprehensible patterns that mirror exactly what we might expect from artificial interstellar communication. In March 2024, engineers achieved a breakthrough by successfully decoding meaningful signals from the corrupted transmission. The recovered message contained a complete memory readout from the flight data subsystem, including operational codes and spacecraft status information. Yet the communication challenges persist due to the staggering distances involved, with signals requiring 22.5 hours each way between Earth and the wandering probe. Every troubleshooting command dispatched to Voyager demands nearly 2 complete days for result confirmation. The communication delay transforms simple repairs into week-long endeavors, highlighting the immense challenges of maintaining contact across interstellar distances. Engineers believe the anomaly originated from a failed chip in the flight data subsystem, possibly damaged by cosmic radiation, or simply deteriorated after 48 years of continuous operation. While technical explanations appear plausible, the timing of these malfunctions coinciding precisely with 3-eyed Atlas's discovery creates uncomfortable questions about potential interference. Could an approaching interstellar visitor be affecting our most distant spacecraft? Both objects now exist in the identical region between stars where galactic plasma flows and cosmic radiation create challenging electromagnetic environments. Voyager 1 operates within the same interstellar medium that 3I Atlas has been traversing for potentially billions of years. The spacecraft's instruments continue studying solar system boundaries and interstellar conditions that this ancient visitor would have experienced throughout its cosmic journey. These shared environmental factors create possibilities for indirect interaction or deliberate interference. The accessibility of Voyager's signals adds another layer of concern. Amateur radio operators have successfully tracked the spacecraft's transmissions using ground-based equipment, with German AMSAT operators employing a 20-meter dish to receive and verify data against official deep space network stations. This accessibility demonstrates that any advanced intelligence could easily monitor our most distant spacecraft's communications. Voyager's delicate communication system relies on precise antenna pointing and sophisticated signal processing to maintain contact across interstellar distances. The spacecraft employs a 23-watt radio transmitter, higher than typical cellular phone power, yet still requires enormous ground-based antennas to receive signals from billions of miles away. Earth stations use 34-meter dishes coupled with extraordinarily sensitive amplifiers to decode these faint transmissions. Any disruption to this fragile communication link could originate from numerous sources, including electromagnetic interference from passing interstellar objects. The recent communication restoration provides hope that Voyager can continue its mission despite hardware failures, though engineers must reposition and synchronize remaining code sections to restore normal data transmission capabilities. The aging spacecraft operates far beyond its original design parameters, making future failures increasingly probable. Each repair attempt requires extreme patience due to the 45-hour round-trip communication delay, transforming simple diagnostics into marathon troubleshooting sessions that span multiple days. Voyager carries the golden record containing humanity's message to any cosmic intelligence encountering the spacecraft during its eternal journey. The record includes 116 images, natural sounds, spoken greetings in 55 languages, and musical selections representing Earth's cultural diversity. Carl Sagan wrote that the record represents a present from a small distant world with the hopeful message, "We are attempting to survive our time so we may live into yours." The spacecraft's radioisotope thermoelectric generators originally produced 470 watts of electrical power at launch, though output gradually decreases as plutonium fuel naturally decays. Current projections suggest the mission can continue returning scientific data until at least 2025, with possible engineering data transmission extending until 2030. The probe's remarkable longevity demonstrates the engineering excellence required for successful interstellar missions. The parallel timing of Voyager's communication problems and 3I Atlas's approach transcends mere coincidence. If this ancient visitor contains advanced technology, it might be systematically scanning our solar system's electromagnetic environment, potentially interfering with existing communication systems during its reconnaissance operations. Such interference could affect sensitive equipment like Voyager's aging electronics operating at the limits of detectability. The communication anomalies force us to confront an unsettling possibility that our first interstellar ambassador may have encountered something in the cosmic void that changed its behavior. The binary patterns replacing normal telemetry could represent attempted communication from intelligence that recognizes our technological signatures, or interference from systems conducting their own observations of human space activities. As 3I Atlas approaches its October solar eclipse concealment and Voyager continues transmitting corrupted signals from interstellar space, humanity faces questions that challenge our understanding of cosmic solitude. The convergence of these events, our spacecraft's mysterious communication changes, and an ancient visitor's precisely timed arrival, suggests patterns too complex for coincidence. Whether 3I Atlas represents natural phenomenon or artificial technology, its approach coincides with humanity's first experience of interstellar communication difficulties. Our most distant voice in the cosmic dark has begun speaking in alien patterns just as something ancient and mysterious approaches from the same infinite void. The Golden Record continues its journey outward while 3OA Atlas races inward, carrying secrets that span billions of years. Two messengers crossing in the darkness between stars, one bearing humanity's hopes for peaceful contact, the other potentially carrying answers to questions we never thought to ask. As October approaches and our observational capabilities prepare for 3 months of solar eclipse blindness, we must consider whether Voyager's communication crisis represents technical failure or first contact through our own technology. The ancient visitor approaches while our interstellar ambassador speaks in tongues we cannot understand, creating a cosmic conversation that may determine humanity's future among the stars. The universe has remained silent for so long that we assumed we were alone. Now, as signals corrupt and ancient objects approach with impossible precision, we face the possibility that the silence was never empty. It was simply waiting for the right moment to respond to our century of calling into the dark. The possibility remains deeply speculative yet profoundly troubling. Voyager carries humanity's golden record message into the identical interstellar realm where 3I Atlas has been wandering for eons. Our spacecraft represents our species' inaugural ambassador to the cosmic community, broadcasting peaceful intentions through both its scientific mission and precious cultural cargo. If 3I Atlas represents a direct response to human electromagnetic signals, Voyager's status as our interstellar emissary makes it a natural target for investigation or communication attempts. An intelligence capable of traversing the galaxy for billions of years would immediately recognize the artificial nature of our probe's transmissions and golden record contents. The corrupted binary patterns replacing Voyager's normal telemetry could represent attempted communication from intelligence that has discovered our technological signature floating through the cosmic void. These repeating sequences of ones and zeros mirror exactly what we might expect from artificial systems trying to establish contact through our own technology. As October's solar eclipse approaches, hiding 3I Atlas during its most critical operations, Voyager continues transmitting these mysterious patterns from the interstellar darkness. The timing creates an unprecedented convergence, Lancera's most distant voice speaking in alien tongues, while something ancient races toward our solar system with mathematical precision that defies natural explanation. The whispers from Voyager grow stranger as this primordial visitor approaches from the dark between stars. Two messengers from vastly different worlds are passing through the interstellar medium Mon, one carrying humanity's hopeful introduction to the cosmos, the other potentially bearing responses to questions we never imagined asking. Whether coincidence or cosmic choreography, these parallel events mark a watershed moment in human history. Our century of broadcasting into the void may have finally received its answer, delivered through the corruption of our own interstellar ambassador's voice and the approach of intelligence older than our world.